Hello. Hello. Okay, good evening, students. Uh, First of all, please make sure that you are getting my voice. Anyone? Please write in the chat box. Are you getting my voice clearly? Okay. So as we all know that we have started this 4 to 5 series in which we discuss 5 questions, and every week from mathematics section I discuss 5 important questions which will be helpful for you in your exam, especially for GATE exam. Okay, these questions of engineering mathematics are helpful for students of all the branches. Okay, XE branch, civil branch, mechanical branch, electrical, electronics, because maximum syllabus of engineering mathematics is common. Okay, and this today's set of questions, this is from calculus. So calculus is a common subject for all the students except computer science student. Okay, but in CSE also we get questions of limits. Okay, so here we have included questions from limits, so it means those will help CSE students also. Okay, so now we are going to start solving questions. What you have to do, I will show you the question. You have to solve it with me, and then we will discuss the final answer. Okay, so let us start. And here is the first question for you. So this question is from limits, and limit is important for all branches. Okay, even for computer science student also it is important. And in electrical, electronics, civil, mechanical, XE, every branch may contain questions from this topic limits. So solve this problem and then we will check the answer. What is the answer to this problem of limit? Please solve and tell me the answer in the chat box. I am giving you sufficient time to solve the problem. So try to find out the answer and write the answer in the chat box, please. And the question is, limit extends to 0, e to the power x minus e to the power minus x minus 2x upon sine cube x. Okay, this is the limit. Okay, so now I did not get answer from any of the student. So I am going to solve this problem. Please watch the solution. You know, in questions on limits, especially in GATE exam, the indeterminate forms are very important. And many times we have got questions based on expansions. Okay, so we should know the expansion of basic functions e to the power x, e to the power minus x, sine x, log 1 plus x, log 1 minus x. Okay, these all expansions are important for you for GATE exam. I request all of you to remember all the basic expansions. Okay, Taylor expansions of functions about the point x equal to 0. You should also know the Taylor series formula to expand a function fx about x equal to a. But the main requirement is remembering the basic expansions about x equal to 0. Okay, because you can solve many questions of limits using those expansions. Now coming to the solution, first of all, what is the first step in finding limit? We put the value at which we are going to calculate the limit. So x equal to 0, we will put x equal to 0. So e to the power 0 is 1 minus 1, 0, 0, 0. So what we are getting? We are getting 0 by 0 form, which is an indeterminate form. Okay. Now, when we get 0 by 0 form, we have one option of using L'Hospital's rule. We can use L'Hospital rule here. Another option is use of expansions. If we have functions involving e to the power x, e to the power minus x, sine x, cos x, then there is another approach of using expansions also. Okay. So here, let us use expansion e to the power x. What is the expansion of e to the power x about x equal to 0? It is 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x to the power 4 upon 4 factorial and so on up to infinity. So this is our e to the power x function. Minus, then we have e to the power minus x. So we can get e to the power minus x by replacing x by minus x. So we get 1 minus x plus x square upon 2 factorial minus x cube upon 3 factorial and so on up to infinity. And then we have minus 2x. So minus 2x. And keep the sine cube x same, sine cube x. Okay. And the limit is x tends to 0. Right? We can write this limit in this form. Now we can see that 1 minus 1. So 1 and 1 are cancelled. Okay. Then what we get? X or minus minus plus x. So we get 2x actually. So this 2x and this minus 2x are cancelled. Now x square upon 2 factorial and minus x square upon 2 factorial cancelled. Then x cube upon 3 factorial and minus minus plus x cube upon 3 factorial. These two are added. Okay. So twice of x cube upon 3 factorial. Right. So what we get? We get limit x tends to 0. After this simplification, we get limit x tends to 0 twice of x cube upon 3 factorial plus now x to the power 5 upon 5 factorial and so on. Okay. Divided by sine cube x. All other terms are cancelled. We have only odd powers of x in numerators, and in the denominator we have factorial of that power and twice, because this and these are added. यहाँ पे 2x जो बना था, that was cancelled by minus 2x. Okay. So now we have to compute this limit. Okay. You can note down up to here. Now I am going to delete this side. Coming to the next point, let us delete this side. Now we have one very important formula which you should remember always, that is limit x tends to 0 sine x upon x, and this is equal to 1. All of you must remember this formula. Limit x tends to 0 sine x upon x is equal to 1. Okay. So here let us take this x cube common. Okay. We can take x cube common. So this becomes twice of limit x tends to 0 x cube upon sine cube x. एक्स क्यूब कॉमन लिया हमने और नीचे भी एक्स क्यूब साइन क्यूब एक्स हो जाएगा आपका मल्टीप्लाइड बाई ओके इसके प्रोडक्ट में हम क्या लिखेंगे मल्टीप्लाइड बाई this 1/3 factorial means 1/6 okay 1/6 plus x square upon 5 factorial plus and so on this one now this limit x tends to 0 x cube upon sine cube x become 1 okay this become 1 and putting x equal to 0 in the remaining terms only this is left so what is left 2 into 1 into 1/6 so 1/3 so B is the right answer here this one okay and one important point you can remember that limit x tends to 0 sine to the power mx upon x to the power m okay for any positive integer m or negative integer m this quantity is always equal to 1 because this is 1 to the power m which is 1 that is why we have written this one and putting x equal to 0 here x square 0 हो जाएगा x to the power 4 0 हो जाएगा so we will get 2 into 1/6 equal to 1/3 okay so expansions are important and some basic formula which we have used these are important things coming to the next question number 2 ये आपको सभी को याद रखना है एक्सपेंशंस के बारे में ठीक है लिमिट के कंप्यूटेशन में now what is the second question come to second question this one try to find out the answer okay this is limit x tends to infinity x square sine 1/x minus x upon 1 minus mod x you have to compute this limit so Ketul Shah has answered the question to answer to question number 1 correctly tell me the answer to question number 2 Ketul, what is the answer to this second question? Okay, so this time you are getting option number C. Very. Let us check it. Any other student who want to answer? Ketul is getting answer C. Any other student present in the class who want to answer this? Okay, so now let us discuss the solution to this problem. Question number 2. What is the right answer? Let us discuss. Generally nowadays they are asking questions based on limit x tends to infinity in exam okay so we have to focus on such questions in which limit x tends to infinity or minus infinity x tends to infinity means x is a very large number x is approaching towards a very large number means very large positive number so we can say that x is positive if x is approaching infinity means x is very large clearly x is a positive number okay so if x is a positive number what we can say about mod x this mod x is just equal to x because mod 1000 is what 1000 mod 20,000 is what 20,000 so when x is a very large number it is positive number clearly then mod x is equal to what x so here we can write x no problem okay so this is equal to limit x tends to infinity, x square sine 1 upon x, okay, minus x divided by 1 minus x. Now let us separate these two terms. Okay, we have this function. So if we separate out the terms, limit x tends to infinity, this x square sine 1 upon x, okay, x square sine 1 upon x upon 1 minus x, or minus limit x tends to infinity, this x, okay, this is minus na, so x upon 1 minus x, right? Now we have to evaluate this limit as well as this limit. This is simple answer. This will give us a simple answer, that will be equal to what? 1 upon minus 1. So it is minus 1 actually. Okay. This is minus 1. How is it minus 1? I will tell you separately by using a formula also. We can divide both numerator and denominator by x. So we get 1 upon x minus 1. Putting x tends to infinity, we get this term 0. So 1 upon 0 minus 1. So this is minus 1 actually, or minus minus plus. So this quantity become plus 1. We have to just compute this one. Now limit x tends to infinity. Okay, this is 1 upon 1 minus x. Okay, no problem. So first in the numerator we have x square into, let us use the expansion of sine theta. Do you remember what is the Taylor expansion of sine x? Okay, so sine x is equal to, we know that x minus x cube divided by 3 factorial plus x to the power 5 divided by 5 factorial and so on. Okay, this is sine x which is valid for all x. So we can replace this x by 1 upon x. So sine 1 upon x is what? 1 upon x, right? Sine 1 upon x is 1 upon x minus 1 upon x cube into 3 factorial, or plus 1 upon x to the power 5 into 5 factorial minus and so on, divided by, now take x common from this denominator. So x into 1 upon x minus 1. And this was minus minus plus 1. So plus 1, here we have this quantity plus 1 and we have to compute this. हमने क्या किया, sin 1 upon x का expansion यूज कर लिया और यहाँ पे डिनोमिनेटर को हमने x से डिवाइड कर दिया, 1 upon x minus 1. Okay, now this x and 1x from this get cancelled. यहां से एक x को कैंसिल करेंगे एक न्यूमरेटर वाले x के साथ. We have x here now after cancelling this, and this x can be multiplied inside. So when we multiply this x inside, this become x upon x means 1. X upon x is 1 minus 1 upon 6x square, this quantity, and plus dot dot dot. Okay, so now we can put x tends to infinity. So 1 upon infinity is 0. So here we get minus 1. This becomes 0. All the terms become 0 except this 1. So we have 1 upon minus 1. So this is minus 1. So equal to minus 1, or a plus 1 equal to what? 0. So our answer to this problem is 0. So answer given by Ketal Saha is absolutely correct. C is the right answer. Okay, and please remember the concepts which we have used here. Generally, whenever limit x tends to infinity, we have a common approach of dividing by x, so that x comes in the denominators to make the terms 0. So we should use this approach. So in this problem, we have used one result that this is equal to 1. So here I am telling you one important formula which you have to remember always. Very important formula. You may get questions based on that formula also. What is that formula? Now let us discuss that. We have limit x tends to infinity. Okay. Now we have a naught x to the power m plus a1 x to the power m minus 1 plus am. This is a polynomial of degree m divided by b naught x to the power n plus b1 x to the power n minus 1 plus bn. So both numerator and denominator are polynomials in x. Numerator is a polynomial of degree m, denominator is a polynomial of degree n. So equal to what? We can write equal to a naught upon v naught if m is equal to n. If both numerator and denominator are the polynomials of the same degree, then our answer will be coefficient of highest power of x in the numerator, that is a naught here, divided by coefficient of the highest power of x in the denominator, that is b naught. So a naught upon b naught will be the right answer. If m is less than n, means if degree of numerator is less than degree of denominator, then our answer is 0. And if m is greater than n and the product of a naught b naught is positive, means both are of same sign, then our answer is plus infinity. That limit is said to be does not exist. Okay, does not exist finitely. And if m greater than n but product of a naught b naught is negative, means both are of opposite sign, then our answer is minus infinity. So you can directly remember this result and you can use it in various problems. Okay. Now come to next problem. Question number 3. What is the question number 3? ये फॉर्मूला इंपॉर्टेंट है, प्लीज इसको याद रखना है सभी जो बच्चे जो गेट की तैयारी कर रहे हैं, ठीक है, या इंजीनियरिंग सर्विसेज की तैयारी करना है, जहां पे इंजीनियरिंग मैथमेटिक्स आता है आपके सिलेबस में, कंप्यूटर एग्जाम में आपको ये फॉर्मूला याद रखना है. कमिंग टू द नेक्स्ट क्वेश्चन नंबर 3. This question is based on Rolle's theorem. Okay, so in our syllabus there are two very important theorems, Rolle's theorem and Lagrange's mean value theorem. Okay, so all the aspirants must remember the concepts of these two theorems, Rolle's theorem and mean value theorem. Okay, so if you remember the concept right now, then you can solve this question. Tell me the answer. What is the answer? Okay, so Ketul Saha, what is the answer now? Question number 3. You have answered 2 questions correctly. That is very good. Now tell me the answer to this problem also. And other student also You should try answering the question in the chat box. Any one of you who got the answer, please write in the chat box. Okay, so now I am going to explain this problem and let us try to find out the answer. Do you know the statement of Rolle's theorem? What is the statement of Rolle's theorem? We have a function. Suppose this is our x-axis, right? Now we have a function, say fx. This is y equal to fx. Okay. Now we have 2 points, say P and Q. Okay. We have P and Q. 2 points. We can take A or B also. Any 2 points we can take. Okay. So suppose we have 2 points P and Q such that Fp is equal to Fq. Means value of the function at these 2 points is same. This and this both are at the same height. Okay. Fp is equal to Fq. This function is continuous in the closed interval P to Q. यहां से यहां तक फंक्शन आपका जो है क्या है, कंटिन्यूसली वेरी कर रहा है, कहीं पे ब्रेक नहीं हो रहा है. ठीक है. And also this function is differentiable at each point in the interval open interval P to Q or at each point between P and Q. P और Q के बीच में हर जगह फंक्शन क्या है आपका, डिफरेंशिएबल है. सो स्मूथली कर्व वेरी कर रहा है. देयर इज नो कॉर्नर पॉइंट, ओके, बिटवीन P and Q. If these 3 conditions fulfilled, then according to this theorem, there exists at least one real number, say C, such that f dash C is equal to 0. ओके. इन दोनों के बीच में कहीं ना कहीं पे एक नंबर C होगा, मिनिमम 1 नंबर, कि जहां पे डेरिवेटिव की वैल्यू कितना आएगा, 0 आएगा. ये हमारा रोल्स थ्योरम का स्टेटमेंट होता है. ओके. सो यहां पे we are given a function in this problem. This one is the function fx and Rolle's theorem holds in the interval 1 to 2. So this P to Q interval is 1 to 2. Okay. P is 1, Q is 2. So first of all, for the applicability of this Rolle's theorem, the value of the function at both 1 and 2 must be equal. So we must have f1 equal to f2. Okay. This is the first requirement for the applicability of Rolle's theorem. So Ketul is getting 171. Okay, let us check Ketul. So f1 is what? Putting x equal to 1 here. So 1 plus a plus b. This is f1 and this is equal to f2. So putting x equal to 2 here. So 8 plus 4a or plus 2b. Okay. Now we get 4a minus a, 3a plus 2b minus b or equal to 1 minus 8 minus 7. This has the first relation between a and b. Okay. From this statement fp equal to fq. Now Rolle's theorem holds in the interval 1 to 2 at x equal to 4 by 3. Means जो point हमारा c है, that is 4 by 3. So f dash 4 by 3 must be equal to what? 0. So first of all, we need to compute f dash x here. So what is f dash x? F dash x is equal to 3x square, okay, plus 2ax or plus b. This is f dash x. Now f dash 4 by 3 must be equal to 0. So 3 into 4 by 3, x equal to 4 by 3 put करेंगे यहाँ पे. So 16 by 9 plus 2a and x is equal to 4 by 3 here also, or plus b. And this quantity must be equal to what? 0. Okay. So now after the simplification of this, let me delete first this side. Okay. So this is 3, 16 by 3. We get here 16 by 3 plus 8a upon 3 or plus 3b upon 3 equal to 0. Okay. So 8a plus 3b equal to minus 16. So this is the second equation between a and b. We have two equations in a and b, and we have to solve these two equations now. So we can multiply this with 3. So 9a plus 3b or equal to minus 21. इसको 3 से multiply कर दिया first equation को. Now subtracting this second equation from the first, this minus this. So 8 minus 9 means minus a, cancelled, equal to what? 5, which implies that a is equal to minus 5. So we are getting a equal to minus 5 first. Now putting a equal to minus 5 here, what is b equal to? This b is equal to, from this equation, minus 7 or minus 3a. So equal to 8. So we are getting b equal to 8. Okay, first we have obtained the values of a and b to determine the polynomial uniquely. Okay, now we can easily compute this f dash a. We have to compute this f dash a means f dash minus 5 or plus f double dash b means f double dash 8. We have to add these two resultants. Okay, so you can note down up to here what two conditions we have used. We have used fp equal to fq and f dash 4 by 3 is equal to 0. Now let us write down the polynomial fx finally. Okay, what is the polynomial fx? I am deleting this side now. You have to write it yourself. So our fx is equal to x cube. What is a equal to minus 5? So minus 5x square, or b is 8, so plus 8x. This is fx. Now what is f dash x? It is 3x square minus 10x plus 8. And what is f double dash x? It is 6x minus 10. Okay. Now put values x equal to minus 5, this one, to calculate f dash minus 5 here. So our f dash minus 5 is equal to minus 5 square is 25, 75 or plus 50 or plus 8. Okay. So it becomes 75 plus 50 is 125 or plus 8, 133. Now f double dash 8. This f double dash 8 is equal to what? Putting x equal to 8 here. So 48 minus 10, 38. And what is the sum of these two? 133 plus 38. We have to add these two numbers. 171. So answer is 171. So Ayan, your answer 143 is incorrect, and Ketul has answered correctly. 171 is the right answer. Is this clear to all of you? What kind of questions they may ask you based on Rolle's theorem, mean value theorem? You have to revise these two theorems from the single variable calculus. Now coming to next problem, question number 4. ओके ये कैलकुलेशन को प्रॉपरली सभी को करना है और 171 आंसर वी आर गेटिंग. कमिंग टू नेक्स्ट क्वेश्चन नंबर 4. Read the question carefully and tell me the right answer. Tangent and normal is also a very important topic, especially for GATE exam. They ask questions from this topic also, tangent and normal. So try to solve this. So write the answer in the chat box if any one of you got the answer. Ayan, Ketul. Okay, Venkata Kishore is getting option number D, means fourth quadrant. Any other student, please answer immediately because now I am going to solve this problem. Okay, so the point of intersection of the tangent and normal, okay, at the point 1A and 1B, we have a curve given to us. This is a curve and 1A, 1B are 2 points on this curve. Okay, so both points have x coordinate equal to 1. Okay, but y coordinate are not given to us. They are given in as A and B. Okay, so first of all, let us try to find out the y coordinate here A and here B. In both cases, we have x coordinate equal to 1. So let us put x equal to 1 in this curve. So we get y square equal to 3 minus 1 minus y or plus 4, which gives us y square plus y, or this is 6, so minus 6 or equal to 0, which can be written as y square plus 3y minus 2y minus 6 equal to 0. So y, taking y common, so y into y plus 3, taking minus 2 common, so y plus 3 or equal to 0. So we get y equal to 2 and minus 3. We have got the y coordinates 2 and minus 3. Now they are saying that a is greater than b. So 2 is greater than minus 3. So clearly this point a is 2. So we have 1 comma 2 and another point is 1 comma minus 3. Okay. Now point of intersection of the tangent and normal respectively. So tangent at this point and normal at this point we have to draw, and then we have to find the intersection point of the tangent and normal. Okay. So now let us try to calculate the equation of tangent as well as normal. Okay. This calculation I hope clear to everyone. So we can delete this now. Okay. आपको बस x equal to 1 put करके y coordinate आपने compute किए 2 and minus 3, and we have decided which one is a. A is greater than b. So this is a, this is b. Now our curve is y square equal to 3x minus x square minus y plus 4, and we have a point say p 1 comma 2, and we have to find the equation of the tangent to this curve at this point. Okay, so tangent is a straight line which passes through this point, which requires slope. We know that slope of a line is equal to the slope of a line is equal to slope of the tangent line equal to value of the derivative at that point. So value of dy upon dx at that point will give us the slope. We will differentiate both sides with respect to x. So 2y multiplied by dy upon dx. Okay, differentiating both sides with respect to x equal to 3 here minus 2x minus dy upon dx और plus 0. Okay, 4 का डेरिवेटिव कितना होगा 0. Now putting x equal to 1 and y equal to 2, because we need to compute value of derivative at this point, dy upon dx at this point. So putting y equal to 2, x equal to 1. So this becomes 4 dy upon dx equal to 3 minus 2, so 1, or minus dy upon dx, which give us dy upon dx equal to, dy upon dx is equal to what? 1 upon 5. Okay, dy upon dx is equal to 1 upon 5, because it becomes 5 dy upon dx equal to 1. So slope of the tangent to this curve at this point is 1 upon 5. Now using the formula y minus y1 equal to m into x minus x1. What does this equation represent? Equation of a line passing through x1, y1 and having slope m. Using this formula we can calculate the equation of the tangent to this curve at this point. Okay. So y minus y1, what is y1? 2, equal to m 1 upon 5 into x minus 1. So 5y minus 10 equal to x minus 1, or we get x minus 5y equal to minus 9. This is the equation of the tangent. Okay. After calculating equation of tangent, now we have to compute equation of the normal to this curve at the point 1 comma b or 1 comma minus 3. So come to the second situation, calculation of equation of normal. Okay. So again, let us take another point. Our another point is this one, 1 comma minus 3, where we have to calculate the equation of the normal. Okay. So first we will compute equation of the tangent at this point, that will be obtained using dy upon dx, and then we know that the product of slopes of perpendicular lines is equal to minus 1. Okay, so slope of the normal is equal to minus 1 upon slope of the tangent. So slope of the normal will be equal to minus 1 upon value of dy upon dx at this point. So again we need dy upon dx. So we need to differentiate this again, and we have already calculated this derivative. 2y into dy upon dx equal to 3 minus 2x minus dy upon dx. So now we have to put this point 1 comma minus 3. Okay, so let us put y equal to minus 3, this minus 3 here. So minus 6 dy upon dx equal to x is again 1. So 3 minus 2, 1 minus dy upon dx. Okay, so this can be transferred to this side. So we get minus 5 dy upon dx equal to 1. So dy upon dx is equal to what? This is equal to minus 1 upon 5. This is the value of derivative. So what will be the slope of normal? Negative of reciprocal of this. So that will be 1 upon minus 1 upon 5. So 5. So slope of normal will be 5. Slope of normal is 5. And normal is drawn at this point. This is the foot of the normal. So what is the equation of the normal? We can easily write the equation. Again using this formula. Okay. So y minus 3. So plus 3 equal to m is 5 into x minus 1. Okay. So y plus 3 is equal to 5x minus 5, or 5x minus y is equal to 8. So we have two equations, equation of tangent and equation of normal. We have to solve these two and we can calculate the intersection point. Okay. So in which quadrant that intersection point lies, that we can easily decide. Now how can we solve these two equations? Let us finally compute the answer now. So we can use elimination. Here we have x. So we can multiply this by 5. So we have 5x minus 25y or equal to minus 45. Okay. Now this minus this. Let us make the subtraction from this to this. So 5 से 5 cancel हो जाएगा. Minus y और plus का 24y. Here we get 24y or equal to 8 minus 45. So 53. So our y is coming to be 53 upon 24. Y is equal to 53 upon 24. Okay. Now we have to compute x equal to. We can put the value of y here and we can compute the x. So tell me now in which quadrant this point is lying. Ketul, how you are getting option number D? Just check. Venkata, which quadrant you are getting actually? Because y is coming to be positive, na? 53 upon 24. Okay, Venkata. So what is the right answer? Calculate x equal to. We have y is equal to 53 upon 24. You put this y here and tell me what is x equal to. Okay. So x is equal to 5y minus 9. 5y का मतलब 265 upon 24 or minus 9. Okay. So equal to 265 minus 216 upon 24. This is also coming to be positive. So we are getting first quadrant actually because both x and y are coming to be positive. So our answer is 1. So this time Ketul Saha, there is a mistake in your answer, but in the previous questions you have done very well. So is this clear to all of you? Very important problem, and in GATE exam maximum difficulty level can be only this. Okay. Now coming to the next problem. Question number 5. So tell me, question number 5, more than one may be correct. Okay. And here we have 5 options, A, B, C, D, E. None of the above. And more than one may be correct. So tell me what are the correct answers in this problem. Question number 5. So maxima and minima. In your exam, there are two type of questions on maxima minima theory. One is finding points of maxima or minima, at which value of x you get a maxima or minima. Category 1. Another category is to find the absolute maximum or minimum values of the function. दो तरह के क्वेश्चन एग्जाम में बनेंगे कि भाई कोई फंक्शन गिवन है, उसका पॉइंट ऑफ मैक्सिमा या मिनिमा कहां पे है, तो ये बताना होता है, या उस फंक्शन की ओवरऑल मैक्सिमम वैल्यू या मिनिमम वैल्यू कितनी है, ये आपको आइडेंटिफाई करना होता है. सबसे इंपॉर्टेंट कैटेगरी दो ही होती हैं गेट के एग्जाम में. ओके, दोनों को आपको याद रखना है. So in question number 5, if you are getting any one option correct, tell me, then I will solve this. Fx is equal to this. You can see that this is x square e to the power minus x square, which is a continuous as well as differentiable function. This function is everywhere continuous, everywhere differentiable. Okay. Now, to find the point of maxima or minima, we need to compute the stationary points of this function, because this is differentiable everywhere. So the critical point are only the stationary point where there is a possibility of maxima or minima. Where is the possibility of local maxima or local minima? At the critical points. What are the critical points? The points where derivative is 0 or function is not differentiable. We are saying that this function is everywhere differentiable. So the critical points are only the points where derivative is 0. Those are stationary points. So जो भी maxima या minima आएगा, that will come at stationary points only. Okay. So we need to solve f dash x equal to 0 to find the stationary points. First step, right? So let us compute f dash x equal to. We have a product of two functions. One is x square, another is e to the power minus x square. So we need to use the product rule. Okay. So first function, that is x square multiplied by derivative of the second. So e to the power minus x square, and derivative of minus x square is minus 2x, plus e to the power minus x square multiplied by derivative of x square, that is 2x. Okay. Now try to take the common, equal to, so e to the power minus x square can be taken as common. This 2x can also be taken as common into 2x. So what is left? Whole quantity has been taken common. So 1, this 1, yahan se le raha hu main pehle 1, and minus, this is x square. Okay. So this is the f dash x, which can also be written as equal to e to the power minus x square into, okay, 2x, this 2x, or minus 2x cube. Now, what are the points where this derivative is coming to be 0? At x equal to 0, at x equal to 1, or x equal to minus 1, this f dash x is coming to be 0. So there are three stationary points, 0, 1, and minus 1. Okay. E to the power minus x square is not 0 anywhere. This will always be positive. So the only stationary points are these three. So possibility of maxima or minima is at these points only, 0, 1 or minus 1. जो भी मैक्सिमम मिनिमा आपका आएगा वो इन्हीं में से डिसाइड करना होगा आपको. ओके, स्टेशनरी पॉइंट्स में से. नाउ at which point we get maxima or minima, this will be decided using second order derivative test. What is the use of second order derivative test? To decide whether a function has local maxima or minima at a point. Okay, so we need to compute the second order derivative. By converting this into this form will help us in evaluating the double integral. Okay, sorry, double derivative, f double dash x. So now let us compute f double dash x, and this is equal to, again we will use product rule, first function, second function. Okay, so e to the power minus x square into first function into derivative of the second, so 2 minus 6x square, okay, plus Now this second function, that is 2x minus 2x cube multiplied by derivative of the first, so e to the power minus x square or into में minus 2x, this one, this is our double derivative. We will compute the value of the double derivative at each of these 3 points, this and this, and then we will decide which is a local maxima or local minima point. So Ayan is answering option number A. Let us check the final answer correctly. And you should have a good command over differentiation. Okay, you should know how to differentiate, how to integrate the functions. Okay, so first of all, let us compute f double dash 0 equal to, so we will put x equal to 0 in the double derivative. This will become 0, this term. Okay, so this is 0, ये दोनों प्रोडक्ट में है, this into this. Okay, तो ये पूरा आपका 0 हो जाएगा और यहां पे 0 पुट करेंगे, so we will get e to the power 0 is 1, so what we are getting 2, it is coming to be 2. So it means x equal to 0 is a point of a local minima. Okay, x equal to 0 is a point of local minima or simply minima. ओके, x इक्वल टू 0 पे हमें एक मिनिमम मिल रहा है, यहां पे लिख सकते हैं 0 पे क्या है आपका मिनिमा. अगर डबल डेरिवेटिव आपका आता है पॉजिटिव तो उस पॉइंट पे बोलते हैं मिनिमा, डबल डेरिवेटिव आता है नेगेटिव देन वी से दैट पॉइंट इज लोकल मैक्सिमा. ओके, नाउ f double dash 1, let us compute f double dash 1 equal to, so putting x equal to 1 now, अगर हम 1 रखेंगे देखो यहां पे तो ये कितना हो जाएगा 2 minus 2, this 2 और minus 2, this become 0 because x equal to 1 पे 2 है और ये भी 2 है, ये पूरा ही 0 हो जाएगा. ठीक है, और यहां पे हमने x equal to 1 पुट किया, so what we get 2 minus 6, so minus 4. okay, और ये e to the power minus 1, so minus 4 upon e which is a positive number, so we have a minima at x equal to 1. Sorry, maxima. We have a maxima at x equal to 1. Now we will put x equal to minus 1. So f double dash minus 1 equal to what? Let us put x equal to minus 1. So this time this is negative 2 minus 6 minus 4 और ये आपका यहाँ पे e की पावर minus 1 होगा, तो minus 4 upon e this one. एंड यहां पे हम क्या रखेंगे माइनस 1 और माइनस 2, ये प्लस में चला जाएगा प्रोडक्ट में यहाँ पे, बट ये आपका नेगेटिव आ जाएगा तो ये भी माइनस में ही आएगा सारा, सो ये नेगेटिव ही आ रहा है. सो मैक्सिमा अगेन वी आर गेटिंग मैक्सिमा एट x इक्वल टू माइनस 1. सो माइनस 1 पे मैक्सिमा, ठीक है, और 0 पे मिनिमा और 1 पे फिर मैक्सिमा, ये सिचुएशन बन रही है माइनस 1 0 और 1 इस तरीके से. So what will be the right answers? Option number A, maxima at minus 1 and 1, minima at x equal to 0, A option. And there is one option C, only one minima. This function has only one minima at x equal to 0. So this is also right. More than one option were correct. So A and C are both correct here. आपका मल्टीपल करेक्ट टाइप के क्वेश्चन भी आपको गेट में मिल सकते हैं और सिंगल करेक्ट वाले भी मिल सकते हैं, तो ध्यान रखना है आपको. ओके, A and C are both correct. Is this clear to all of you? ओके स्टूडेंट्स, सो ये हमारा 4 to 5 सीरीज का मैथमेटिक्स का थर्ड लेक्चर था. ठीक है, इससे पहले भी 2 लेक्चर हो चुके हैं और उनके क्वेश्चंस आपको चैनल के ऊपर प्लेलिस्ट में आप जाके 4 to 5 सीरीज मैथमेटिक्स में सर्च कर सकते हैं, और उन क्वेश्चंस को जिसने सॉल्व नहीं किया है, इफ एनीवन ऑफ यू इज न्यू टू दिस क्लास, आप सभी उनको सॉल्व करें. ठीक है, उनको कलेक्शन को आप ध्यान रखें. डिफरेंट वैरायटी के क्वेश्चंस इस सीरीज के थ्रू हम कवर करेंगे जो आपको डेफिनेटली हेल्प करेंगे एग्जाम में. ठीक है, और अच्छे लेवल के सारे क्वेश्चंस होंगे जिससे आपके सारे कंसेप्ट रिवाइज हो जाएंगे. आप कहीं भी पढ़ रहे हैं, आप सेल्फ स्टडी कर रहे हैं या कहीं और पढ़ रहे हैं, आप सभी को क्वेश्चन सोल्व करने हैं, ये सभी को फायदा होगा इससे एग्जाम में. ओके, और सारी ब्रांचेस के लिए कॉमन है, तो सभी स्टूडेंट्स को इन क्वेश्चंस को सॉल्व करके डेफिनेटली बेनिफिट मिलेगा। अब मेरी जो क्लासेस हैं ये वैसे तो 6 to 8 टाइम में डेली वी हैव क्लासेस, लाइव क्लासेस, बट कुछ टेक्निकल क्लासेस होती हैं, ठीक है, एक्सी ब्रांच के लिए, सिविल ब्रांच के लिए, मैकेनिकल के लिए अलग से। और जो मैथमेटिक्स की क्लास है मेरा शेड्यूल ये 4 to 5 सीरीज का, ये आपका वेडनेसडे को होता है, ठीक है, बुधवार को 7 to 8 का टाइमिंग है, इसको नोट करके रखो, ठीक है। इसमें आपको अच्छे अच्छे क्वेश्चन, जितना आप इन्वॉल्वमेंट दिखाएंगे क्वेश्चन सॉल्व करने में, उतने ही अच्छे लेवल के क्वेश्चन में बनाने के लिए मोटिवेट रहूंगा मैं भी, ठीक है ना। तो आपको फायदा होगा उसका फिर एग्जाम में। ओके, सो नाउ आई एम एंडिंग दिस सेशन। ऑल द बेस्ट, गुड नाइट।